This was a 3-point problem on your test. It was just a straight up ideal gas law problem. When we look at it, remember always write down your variables. You're calculating temperature. We start off with 2 moles of this gas. Volume is 5.0 liters and the pressure 2.46 atmospheres. Now, anytime you're looking at a problem like this, remember you got to make a couple decisions. Number one, do I have to use ideal gas law or can I use combined gas law? And the deciding factor here is they give us moles. So we're going to have to use ideal gas law for that, which is not a big deal. The number two thing, since we're going to use ideal gas law, PV equals nRT, is we got to figure out which R to use. And so remember, there's several different versions of R, but the one that we want is going to include this pressure, atmospheres. And the reason we want to use that value of R is if we don't, then we're going to have to convert this to something else. So it's easy to just choose the value of R that is written in terms of atmospheres. And that number would be 0.0821 liters times atmospheres over mole Kelvin. Alright, from this point, all we're going to do is solve for the variable that we need to solve for. We're going to isolate temperature right here, which means we're going to divide both sides through by nR. So now we're working with T equals PV over nR. Okay, now remember that I'm all about my units and making sure that I double check my work. So I'm going to start a new page here, and I'm going to use dimensional analysis to make sure that I'm not going to screw up anything. Because this is my little checkpoint. This is going to help me decide before I finish that problem and move on to my next one, did I do everything right? Because whenever you get a lot of these variables and a lot of these different units, then we can get confused pretty quick, especially if we're dealing with before and after conditions, which we're not here. So I'm just going to rewrite this. Okay, so T, remember I can write it like P over 1 times V over 1 divided by N is 1 over N divided by R is 1 over R. Okay, all I did here was I know that I'm getting ready to account for my units, and see, especially with this R here, I've got units on top and bottom, and that might get kind of crazy for me if I'm not really good at canceling them. So I wanted to be able to just visually do this. So remember, all I did was just expand this out. This is like saying P over 1 times V over 1 divided by N is saying times 1 over N divided by R is saying divided by multiply by the inverse of R, which is 1 over R. Okay. Now I'm just going to plug in my numbers here. My pressure, 2.46 atmospheres. My volume, 5 liters. My number of moles was 2 moles. Okay, now remember, if R is on the bottom, that means I have to flip. I'm just going to flip everything up here. So I'm going to put mole Kelvin on top and 0.0821 liter atmosphere on the bottom. Before I touch my calculator, I need to make sure I got this set up correctly to end up with the temperature I need. So I look over here, atmospheres cancels atmospheres, liter is going to cancel liter, mole is going to cancel mole. Therefore, I'm going to be left with the unit Kelvin. And then I ask myself, does that match up with what I'm actually looking for? And yes, it does. Okay, so now all I'm going to do is I'm going to input into my calculator 2.46 times 5 equals, and then I'm going to hit my divider sign, divided by 2, equals, and then I can hit my dividing side again and equal. So the final answer should come out to be in the neighborhood of 75 degrees Kelvin, or 75 Kelvin. Okay, remember, anytime you're using your calculator to multiply these, you'll multiply everything on the top, and then you'll just divide by the things that are on the bottom to get your final answer.